Good morning, Year 12 Physics students. Today we're going to be doing forces acting at angles, and this question here is one I made up about a possum. So I was out trapping with my daughter in the weekend, and she grabbed the possum by its tail as it was trying to run away. So she's grabbed it, but her tail's up on an angle here, like that. We'll draw in the tail, something like that, and she's been pulling on it really hard. We'll make this line here the force vector. It's this one here. Put an arrow on it. And she's applied 375 newtons of force. This force is made up of a horizontal component, just as we did with projectile motion. We're going to do the same with forces, where we're going to divide them into horizontal and vertical components. So the horizontal component there, we'll label it as force subscript horizontal. This one here is force subscript vertical. The angle in here was 38.0 degrees. So you can see we've got three significant figures on each of those. Now our question here is, how much force, or forward force, did the possum need to generate to accelerate forward? So the possum's going to be generating a force this way, forward, as it's trying to run away from her. But she's got this component here going backwards. You can see the length of that arrow is significantly shorter than this one. So to solve this kind of question, you need to go to trigonometry. So we'll write down our SOHCAHTOA. And what we've got here in regard from this angle is we've got the adjacent and we've got the hypotenuse. So we're going to be going with cosine. So cos angle 38.0 is equal to adjacent divided by hypotenuse. So adjacent over hypotenuse, and the adjacent angle, we'll customize it, is called FH in this case, and the hypotenuse is 375. Now we make FH the subject, and that is equal to cos angle 38.0 times 375. And that will give you an answer of 295.5. And then that rounds, because we've got three significant figures there, 3 there, that should give us 396 newtons for the horizontal component. Now in regard to this question, if the possum generates a number that's greater than 395, then the possum will accelerate forwards. If the possum generates a forward force less than 396, then it will be pulled backwards by my daughter. So, but if it actually pulls exactly 396 as well, then they'll be set in equilibrium where the forces are equal and opposite, and there's no acceleration at all. So, interesting scenario. Move on to this question here. So if the possum generated 350 newtons, that one should be 296, sorry. If it generated 350 newtons, how fast would the 22 kilogram girl accelerate? So we've got to find what the net force is first. So force net is going to equal 350, which is the force generated by the possum, minus the force generated by my daughter. So minus 296. And that gives us an answer of 54 newtons. So that's the unbalanced force in this case. Now to find the amount of acceleration, we have to go to an old favorite, which is F is equal to mass times acceleration. This time the acceleration is not due to weight force or due to gravity. Its acceleration is due to the possum. We're ignoring vertical parts of this setup. So it's purely just horizontal. So therefore we put in the mass of the girl, which is 22. And the acceleration is going to be left as A, because that's what we're trying to find out. How would the girl accelerate? We know that force is 350. Now, to rearrange this, we need to divide both sides by 22, and they get to cancel, and we end up with 350 divided by 22, and that gives us A. We'll jump over here. Acceleration is therefore equal to 2.45. However, on this case, we've only got two significant figures there. Therefore, our answer just becomes 2.5 ms minus 2. Hope that helped you. Keep going.